Okay, you really need to read the book to get an idea of what we're going to be doing, and we're going to be doing it in class for the next 2 days. But because I know it's been a while since some of you had to do long division of polynomials, I thought I would do a quick video to remind you of how that's done. So as you're reading the book, which you should do, as you get to example 1, one step in that process is to divide the polynomial x cubed plus x by the polynomial x minus 1. And they do this sort of out in the margin, and it's just there, and then they move on. So what they get is x squared plus x plus 2 plus the fraction 2 over x minus 1. And you go, great. And if you understand that division, then just keep reading. If you wouldn't be able to do that division on your own, this video is for you. So our goal is to figure out how they did that. And in general, if you have a fraction of polynomials, p of x is a polynomial divided by q of x, and the numerator has larger degree than the denominator or the same degree, our goal is to rewrite it like this. So something plus a fraction, where in that fraction now the degree of the numerator is smaller than the degree of the denominator, and then that s of x is just some polynomial. So we turn a rational function into a polynomial plus a fraction, and in our new version of it, the fraction's top has smaller degree than the bottom. Okay, so how do we do this? We have to do long division. So the first thing is to sort of fill in missing terms in both the numerator and denominator. So you want to fill in any powers of x between the highest one and constants with 0. So we're missing an x squared term and we're missing a constant term on top. All right, now we can write it like long division. So back in, I don't know, 3rd grade or so, you had to do long division, and you wrote it, the thing you were going to divide, and then had this sort of box-like thing, and then over to the left the thing you were dividing by, or at least this is how I learned to write it. So we have x cubed plus 0, x squared plus x plus 0, divided by x minus 1. Now how did we do it? In regular long division with numbers, you go, how many times does this thing on the left fit into the first couple of digits of the thing on the right? Write that at the top, multiply and subtract. Same idea, but with x's. So all you do is look at the first term of both of them, the x and the x cubed, and you go, how many x's do I need to make x cubed? Or more accurately, x times what would produce that x cubed? Well, x times x squared would produce that x cubed, so you write an x squared on top. Then you take that x squared and multiply it by the entire thing over on the left. So x squared will be multiplied by that entire x minus 1. And write that below. So what I get is x squared times the x minus 1 is x cubed minus x squared. Okay, so that's underneath. And then I subtract that from what's above it. So x cubed minus x cubed, that goes away. And then I have 0x squared minus negative x squared. Well, that's positive x squared. Right. Now I need to have enough terms down here to work with to match how many terms are on the thing I'm dividing by, that x minus 1. So I bring down the next term, x. Okay, now I look at the first part of each thing again. I'm looking at the x in the x minus 1 and the x squared in this x squared plus x. And I go, x times what would equal that x squared? Well, x times x equals that x squared, so I write that x on top. And multiply that times the entire left-hand thing, x times the entire x minus 1, and write it below. That gives me x times x minus 1 is x squared minus x, and I'll be subtracting it. X squared minus x squared is nothing. X minus negative x is 2x. I need another term, so I bring down that next 0. And then I look at the first part of each, x and 2x. X times what would equal 2x? X times 2 would equal 2x. So I now multiply 2 times everything to the left, and I get 2 times x minus 2 times 1, 2x minus 2. And then subtract 2x minus 2x is nothing, 0 minus negative 2 is 2. And there's nothing left to bring down, and if I try to look at the first parts, I go x times what would equal 2? Well, I'd have to have a fraction, or a fraction with x on the bottom, and we don't want that. So whenever you get down to a place where you have something with lower degree than what you're dividing by, in this case this is a constant and we're dividing by a degree 1 thing, so that's lower, you stop, and whatever's left is the remainder. Right? So the division gave me x squared plus x plus 2 with the remainder of 2. But we can write that as a fraction as x squared plus x plus 2 plus that remainder over x minus 1. So the quotient is the polynomial, x squared plus x plus 2, and then the new fraction is the remainder over what was originally on the bottom, the original denominator. We're going to do one more example, and I encourage you to pause the video and try this one. And if you get stuck, continue watching the video, but pause it after every step and see if you can do what's next. Okay, so I want to do 3x cubed minus 4x squared plus 1 divided by 3x squared plus x minus 2. So I write 3x cubed minus 4x squared plus 0x plus 1, filling in the missing term, and I'm going to divide it by 3x squared plus x minus 2 over there on the left. Okay, what do we do first? We look at the first term in each, 3x squared and 3x cubed. 3x squared times what equals 3x cubed? Well, 3x squared times x equals 3x cubed, so that x goes on top. Then I multiply that x that just went on top by the entire left-hand thing, 3x cubed plus x squared minus 2x. And then I subtract all of that from what's above it. That leaves me with negative 5x squared plus 2x, and then I brought down the 1. Okay, now I'm comparing first terms again, 3x squared and negative 5x squared, that are underlined in purple. And I have to say 3x squared times what would give me negative 5x squared? Well, the x squareds already are there, so I don't need to multiply by any more x's. But I have to multiply by a negative 5 and divide by 3 to get the 3 to turn into a negative 5. So that's negative 5/3 I need to multiply by. When I multiply negative 5/3 times everything on the left, I get a negative 5x squared. But then I get a minus 5/3 x and a plus 10/3. So unpleasant, but we can do it. So I multiplied that negative 5/3 times everything on the left, and now I subtract the results from what's above it. Negative 5x squared minus negative 5x squared goes away. 2x minus negative 5/3 x, that's 6/3 x plus 5/3 x, that's going to be 11/3 x. And 1 minus 10/3, that's 3/3 minus 10/3, that's negative 7/3. So 11/3 x minus 7/3. And at this point I have something of degree 1, right? There's the highest power of x there is x to the 1. What I was dividing by has x squared, x to the 2 in it, so I now have something lower degree than what I was dividing by. So I stop, that's my remainder. And that original fraction, that original rational function, I can rewrite as x minus 5/3, my quotient, plus a new fraction, that is the remainder, 11/3 x minus 7/3, divided by the original denominator, 3x squared plus x minus 2. So in class, we'll see how to use these in integrals. We'll do more of them. It'll be lots of fun. Everybody will want to tear their hair out. It'll be great. I'll see you there.